Find the Thevenin equivalent of the circuit at terminal AB. Okay, I think because of these two dependent sources, we need to do special tricks here. And what I need to do, first one will be to find out the Thevenin voltage. So find VTH. And that is the open circuit voltage at AB, right? In this case, that will equal to VAB. Okay, but then let's set this node here as our ground. So the voltage here will be 0. But if this voltage is 0, VB is 0. Therefore, VAB is equal to VA, which is this node here. So our goal now is to find out what VA is, right? So our goal now is to find out what is VA here, VA. Because if we found VA, we can find the VTH. Okay, and let's extract what more information that we can get from this circuit. This is 5 volt from the ground. So here in this node here, that should be 5, right? Because the difference between two nodes in voltage source should be the value here. Because this one is 0, it has to be 5, right? And similarly, because the magnitude of this dependent source is 3V, we have this node here as 3V. Good. But then we can calculate I from here using Ohm's law. What is I? So we will have I there. I is equal to 5 minus 3V, because the current comes from 5, the node 5, and then it goes to node 3V, right? So I will have 5 minus 3V, and then it is divided by the resistance between them, because this is voltage. To get current, we need to divide it by the resistance. This is 2 kilo ohm, so I just write 2000 here. 2000. Okay, and I think nothing that we can do from this one. Let's see what can we get from the circuit more. So here we will have this current goes down here, but then it will goes there, and then it will goes up here eventually, right? Forming a loop. Okay, we know that this current here is 20I. But then we can calculate what is VAB, right? Or VA. Let's see here. Okay, the current is flowing from the negative terminal and it goes to the positive terminal. So the voltage there is V. So I will have V there is equal to minus. And then the value of the resistance is 25, but we need voltage, so we multiply this by current. So minus 25 multiplied by 20I. Good. And that will be minus 25 multiplied by 20. That will be minus 500. But then we can substitute I here, which is this value here. That will be 5 minus 3V divided by 2000. Okay, so this will cancel into 4, right? So what can we do next? Let's multiply both sides here by 4. So on the left hand side, I will have 4V. And on the right hand side, 4 and 4 will cancel each other. So I will have minus 5 minus 3V. Good. And what can we do next? We will have 4V is equal to minus 5 and then plus 3V. Therefore, our V here is equal to, yeah, let's move this. 4 minus 3 is 1. So I will have V is equal to minus 5 volt. But here, V is parallel with AB here. And that means that our VAB or VA is equal to minus 5 volt. VAB or in this case VA is equal to minus 5 volt. So we also get our Thevenin voltage, which is VTH. And we will have the value of minus 5 volt. Okay, and I think that is good here. Now let's move on to the second step. Okay, usually if we find Thevenin equivalent, we find VTH and then RTH. However, because of this dependent sources, instead of finding RTH, we can find the Norton current. Find IN. What does IN means? IN is the short circuit current at AB. So we short this AB here. But then we need to change the circuit. Okay, let's see here. Okay, I clean up the circuit. And now what we need to find out here is the short circuit current here. Okay, and let's name that current here as IN. Right? IN here. However, if we short this, all the current will flow through this and not this one. So I need to replace that resistor here by open circuit. Okay, maybe let's draw something here like this. Yeah. Okay, I have replaced this resistor with open circuit. Okay, slightly there. Good. And now what can we do from here? Okay, this perfect loops. This is a perfect loop, right? But this one here is connected to the current source. So it will goes here. But then this loop here is the same as this one. So that will be 20I. But then that is the opposite direction of IN. So I will have IN is equal to 20I, right? Minus 20I. Because the direction is to the opposite of each other. But then we need to find out what is I. Let's set this as our ground and we can play the same game as before because this is 5. And then this one is, this one here is, oh no, we don't need to find that. Or we need? Yeah, I think we need to find that. This is 3V. 3V here. However, what is V? V is shorted here, right? So V was here. But it is shorted. But it is because it is shorted to the ground. We know that the voltage here will be 0, right? So we will have 3 multiplied by 0. So we'll have 3 multiplied by 0. That will be 0. Good. So we can have this. So I will have minus 20 multiplied by I. So I will have 5. The current comes from 5. And then the current goes to this node here. But this node is 0. So I will have 5 minus 0. And then divided by 2000. Good. And now we will have minus 20 multiplied by 5. I will have minus 100 divided by 2000. And this is in ampere. I think I will rewrite that in milliampere, right? So I will have IN is equal to minus 100 divided by 2000, then multiplied by 1000. So this will cancel into 2. So we will have our Norton current is equal to minus 50. And the unit here is in milliampere. So we have the second most important value, which is IN. And that is minus 50 milliampere. Good. And now we can find out the third step, which is the Thevenin resistance. So I will need to find out RTH. We can just divide the Thevenin voltage by the current. So I'll have VTH divided by IN. And that will be -5 divided by -50. But this is milliampere, so I will have this multiplied by 10 to the minus 30. So I will have minus 5,000 divided by minus 50. Therefore, I will have RTH is equal to, this one will be 10 ohm. Right? So we will have RTH is 10 ohm. And the last step is just to draw the circuit, equivalent circuit. So I will have VTH here. That is minus, so the sign will be, this one will be minus, and this one will be plus. And this will be 5 volt. And then we will have, that is in series with 10 ohm resistance. 10 ohm. And so we will have this one here as terminal A, and this one here as terminal B. And that is the Thevenin equivalent at terminal AB. Okay, I think that's all for this problem. Thank you for watching. See you in the next video. Bye-bye.